video, I will be taking the problem on a cutout section. Now, what is a cutout section? In that section, we would be having one solid and other solid we will place in such a way that the system, the composite solid which we will get, it is an intersection, or we can say subtraction. It means from one solid we will cut another solid, and whatever remains we will find the CG of that section. So here we have a question related to that concept. The problem is on cutout solid section, and here the question which I have, it is cylinder minus cone. That is, from the cylinder we would be subtracting the cone. Let's read this question. From a cylinder having 200 mm as base and 300 mm as height of cone with same base and height is cut off from the bottom. Calculate the CG of the remaining solid with respect to base. So in this question it is clear that from a cylinder a cone is cut. Cylinder is there and here we have a cone. So first I'll draw the cylinder and from that I will cut the cone. So I'll write this as the solution. Here we are having cylinder of 200 mm diameter of base and 300 mm height. Now, from a cylinder having 200 mm as base, I'll mark the dimensions. (200 mm) is the base of the cone, or here it is the base of the cylinder as well, and 300 mm height. 300 mm as height of cone with same base and height is cut off from the bottom. So having the same base and height, we have a cone which is cut off from this cylinder. The question is calculate the CG of the remaining solid with respect to base. So from the cylinder, if we are cutting this cone, then the section which remains, it is, I am marking that. So in red color which I have shown, this is the section which remains when from the cylinder a cone is cut. Now we have to calculate the CG of the remaining solid with respect to base. So the section which remains, we have to find the center of gravity of that section. In other words, I have to calculate X bar and Y bar. So let us try to solve this problem. In this solution part, I will place this system on an axis. As we see in the diagram, here this composite solid, or we can say the cutout section, actually it is a cutout section, it is symmetric about the vertical axis. Now since it is symmetric about the vertical axis, we can say that X bar distance, we can get it directly. So I'll write down here, this is the Y axis of the cutout section. Since the given section is symmetric about Y axis, therefore CG, center of gravity, lies on Y axis. Hence X bar will be equal to, it will be half of 200. So X bar is 100 mm. This is our first answer. Now after getting X bar, we will calculate Y bar. For Y bar, we require the volume of cylinder and cone and Y values. So let us start with that. Here I'll assume the cylinder to be the first solid and cone will be the second solid. So I will subtract cylinder, I will subtract cone from the cylinder. So here I'll say that since V1 volume of cylinder is equal to pi r square h, therefore it is pi into radius is 100 square into height is 300. So from this I will get the volume of cylinder, that is 3 into 10 raised to 6 pi mm cube. This is V1. Now Y1, it will be equal to, if we have a cylinder, its height is 300, so CG of this cylinder will lie exactly at half. So this is Y1 for us. This is Y1, and I can say that Y1 will be half of 300, so it comes out to be 150 mm. After getting V1 and Y1, now I'll get V2 and Y2. Since V2 volume of the cone, it is given by 1 upon 3 pi r square h. So this is equal to 1 upon 3 pi. Radius of the cone is same as the radius of the cylinder, so it is 100 square into height is also same, it is 300. So from this I will get the value of V2, that comes out to be 1 into 10 raised to 6 pi mm cube. After getting V2 for a cone, here the height is given, it is 300 mm. So for a cone, its CG will lie at h by 4 from the base. So this h by 4 is nothing but Y2. So I'll say that since Y2 is equal to h by 4, and that is 300 divided by 4, so therefore Y2 will be 75 mm. Once we know V1, Y1, V2, Y2, we can go for the calculation of Y bar. After this, now since location of CG with respect to x-axis is given by Y bar is equal to V1 Y1 plus, here I am subtracting, so we have to be careful, this would be negative, this will be negative, V1 Y1 minus V2 Y2 upon V1 minus V2. So here we have to be careful because we are subtracting one solid from the other. Cone is subtracted from the cylinder. So therefore I'll put the values V1 3 into 10 raised to 6 pi, Y1 150 minus V2 1 into 10 raised to 6 pi, Y2 75 upon V1 minus V2, that is 3 10 raised to 6 pi minus 1 into 10 raised to 6 pi. So therefore I will get the value of Y bar as 187.5 mm. Second answer. Now once we have calculated X bar and Y bar, we can show it onto the cutout section. So I'll draw it very fast once again. So CG will lie on y axis. This X bar distance is we have calculated it was 100 mm, and y bar we are getting it as 187.5, and the total height was 300, so just above that. And wherever we are getting the intersection of y-axis and x-axis, that will give us the centroid. So here we are having this, since it is a solid figure, we'll call it as center of gravity. So this is the CG for this cutout section, and as we see, once we have located the CG, we can say that the problem is over.